So in the last video we learned how to graph a sine or cosine function if we had a different amplitude. So in this video we're going to learn how to graph our sine and cosine function if we have a different period. So we're going to look at the same formula we looked at last time, y equals a sine b theta, or y equals a cosine b theta. Okay, the coefficient of theta, the b value we have on each one of these, is going to help us find our period. Now, it isn't our actual period. In order to get that, we're going to have to take b and put it underneath 2 pi, and the resulting value will give us what the period of our function is. For instance, on the parent function, there was a understood 1 on the theta, so you had 2 pi over 1, so the period of our parent functions was 2 pi. So on these functions, we're going to have to use the coefficient of theta to solve for the period. So let's get started. If we look at number 1, we have y equals the sine of 2 theta. Okay, so b, the coefficient of theta, in this case is 2. So my period is going to equal 2 pi over 2. All right, so that means that the 2's are going to cancel out, and my period is simply going to be pi. All right, so if we wanted to graph this, I'm going to come to the end of my graph here on the x-axis, and I'm going to label it pi because that's going to be my period. I'm just going to graph one period for each of these. All right, so now we want to label our midline here. So half of pi would simply be pi over 2. All right, so now that I've labeled that, I can label the quarter marks if I'd like, pi over 4, 3 pi over 4, but generally I find it easier, especially if students are having a little bit of trouble with fractions, that they can actually trip them up. It's not necessary to label the quarter marks. You probably want to be familiar with them enough to know what they are, but as far as labeling them is concerned, if you know what you're doing, I wouldn't even bother with it. So we're going to graph our sine function. So sine starts at 0. It's a positive sine function, so it'll be going upwards first. So at my first quarter mark here, it would be at its maximum. At pi over 2, the halfway point, it'll be back at the midline. At my second quarter mark here, it would be at its minimum. And then lastly here at the period pi, it will be at the midline again. So you would get a sine curve that looks like this. Now, you're going to come to find as we graph these, the way I'm graphing them, that most of the graphs will look the same. The sine graphs will both look the same. The cosine graphs will both look the same. The key thing is to label them correctly. So if I label these pi over 2 and pi, and then I come down here later and I label these two something different, I'm able to tell that this graph has a different period than this graph, even though they might look the same. You can graph them to scale. However, you're going to find that that takes a lot more time and effort and can be a little bit confusing as you start graphing some really big graphs that may go out to like 8 pi or 16 pi or something like that. So typically just making sure you are labeling your axes appropriately will be the best bet to get these answers. So let's go look at number 2. We have y equals cosine of 4 theta. All right, so again, 4 is not my period. I have to use the 4 coefficient of theta, plug it into my formula up here to find out what my period is. So I get 2 pi over 4. So if I reduce this down, I get that my period is going to equal pi over 2. So I'm going to come over here to my graph, and I'm going to put pi over 2 at the very end, because that is my period. So I want to go to the halfway mark and label it. So half of 1/2 is a quarter, so this would be pi over 4. Again, you could label this as pi over 8 and 3 pi over 8, but not necessarily necessary. So it's a cosine graph. It's a positive cosine graph, so this function will start at the maximum at 1. At the next mark, it's going to be at the midline. At the halfway point, it'll be at -1, the minimum. At the next mark, it'll be back at the midline, and then at the period, it will be back at its maximum. All right, so both of those were whole number coefficients of theta. So now let's look at a couple of problems that do not have whole number coefficients of theta. So on number 3, we have y equals sine of theta over 2. Now, a lot of times students want to think that this has a coefficient of 2. that's not correct. The coefficient, or b in this instance, is actually 1/2. We took 1/2 and we multiplied that times theta over 1, and it gave us theta over 2. Okay, so we want to make sure we put 1/2 under 2 pi and not 2, because that'll give us the wrong answer. So our period is going to be 2 pi divided by 1/2. So whenever we divide by fraction, we flip and multiply by its reciprocal. So I get 2 pi over 1 times 2 over 1. So I get a period of 4 pi for this problem. All right, so I'm going to go out here to the end and put 4 pi. I'll label my halfway point 2 pi. I could label my quarter marks 1 pi and 3 pi, but not really necessary. So sine function, positive sine function. So it's going to start at 0. It's going to go up to its maximum at 1 pi. It'll be at the midline at the halfway point. It'll be at its minimum at the third mark, and then back up to the midline for the full period. All right. Again, these two graphs look exactly alike. However, this one has a period that is 1/4 of this graph. And since I've labeled these appropriately, I could see that and I could tell the difference between the two. If you graph them on the same graph, this would have 4 lines before, you would have 4 periods of this before this would complete 1 period. Alright, let's look at our last problem. We have y equals cosine of theta over 3. So again, we have a fraction as our coefficient. So this is 1/3. Right, so we want to make sure we don't put 3 underneath 2 pi. We want to put 1/3. So I'm going to have 2 pi over 1/3. So that's going to give me 2 pi over 1 times 3. So my period here is going to be 6 pi. So that's what I want to label out here at the end, 6 pi. That means our halfway point would be 3 pi. And we'd have 1.5 pi and 4.5 pi for the quarter marks. So positive cosine graph, so we're going to start at the maximum. Our next mark, we're at the midline. Our halfway point, we're at the minimum. Next mark, we're back at the halfway point, the midline. And then at our period, we are back at the maximum. And so again, our cosine graphs look alike. However, this has a period of pi over 2 and 6 pi for the second one. And since I've labeled these correctly, I can tell that there is a difference in their period. So the key thing to keep in mind is if you have a coefficient that is a whole number, so 2, 3, 4, 5, 6, so on and so forth, it's going to give you a shorter period than our usual 2 pi. So notice we have a 2 here, our period is pi. We had a 4 here, our period is pi over 2. So these make our period smaller than the normal period for sine and cosine of 2 pi. If you have a fraction, such as 1/2 or 1/3, it's going to make your period greater than 2 pi. So we had 4 pi here, and we had 6 pi here. So sometimes students have trouble with that since fractions are smaller numbers, but since we're having to flip and multiply, it's going to give us a larger period. So that is how we would graph changes of periods for sine and cosine functions. So soon I'll have up a video of how we can use the amplitude and the period to write the equation for sine and cosine functions, so kind of reverse engineer the process that we just went through. So hope you guys enjoyed the video. Stay tuned for more. Thanks.